All right, 4.1 chain rule. So basically, this is our means of taking a derivative of a composite function. So like the f composed of g of x, basically what happens is we're taking the derivative of the inside multiplied by the derivative of the outside. Not in that order, but anyways, that's what ends up happening. So the chain rule actually says if f is differentiable at the point u is equal to g of x and g is differentiable at x, then the composite function f of g of x and remember sometimes the book will write it like this where it's like fog x is differentiable at x and f of g of x actually let me write it this way. F of g prime of x is equal to f prime of g of x, so the derivative of the outside, times g prime of x, so the derivative of the inside. So we take the derivative of the thing as a whole and then times the derivative of the inside piece.
I have a question. So on the second part of that equation, is that the f prime g of x?
Yes.
And is that a multiplication somewhere?
Yeah.
Okay.
In Leibniz notation, if y equals f of u and u equals g of x, then dy dx is equal to dy du times du dx, where dy du is evaluated at u is equal to g of x. So that probably sounds pretty confusing, is my guess. So I'm going to write it a little simpler for you. The outside-inside rule.
So basically this is the same thing.
Yep.
In
So basically, just to simplify it, if y is equal to f of g of x, then dy dx is equal to f prime of g of x times g prime of x, which I realize is pretty much exactly what was written up there. But the way I would say this is the derivative of the outside times the derivative of the inside. So I'm going to show you a little example of this really fast. So if I am told to take the derivative of sine of x squared plus 4, okay, basically, I could decompose this into two separate functions. I could have f of x be sine of x, and I could have g of x be x squared plus 4. And so basically, I'm taking the derivative of everything that I'm not covering up. Okay, so the derivative of sine, with this still in the parentheses, copied exactly, times the derivative of just the inside of what's in parentheses. Okay, so what this is going to look like is the derivative of the outside. So what is the derivative of sine? Ignore everything else. Cosine. So it's usually the derivative of sine of x is cosine of x. In this case, it's the cosine of everything in here, which is x squared plus 4, times, now we ignore the sine part and we just take the derivative of what's in the parentheses. So what would the derivative of x squared plus 4 be? 2x. So then this comes out to be 2x cosine of x squared plus 4. Hi.
Hey, are you able to pick up?
Yes. Yes, is he leaving? Okay, sounds good. Ethan, you need to go to the office to see your dad. But you're coming back. I'll pause after we finish the last couple lines of notes so that way you don't miss anything.
What about the sign from that part? Like where we got the 2x? Will we not carry over the sign though?
Huh?
Like,
Talking about the SIGN or the SIN?
the SIN.
That's it.
Well, what do you mean? I already took the derivative of that.
So we don't have to.
This is f of g of x. The f of x part is sine of x. The g of x part is the x squared plus 4. So we take the derivative of the outside piece times the derivative of the inside piece.
Would you try to multiply sine throughout the parentheses pieces? What are you trying to do?
No,
Can we do another example?
it was basically.
Well, we're going to, but I'm not going to do another one right yet. I'm going to finish the notes and then we'll pause and actually do homework examples where you'll see it.
Yeah, I guess that's what I was thinking.
That's not a product rule.
Well,
This
yeah.
is the sign of something.
Yeah. I was confused.
All right, finding dy dx parametrically. If all three derivatives exist and dx dt is equal to 0, then dy dx is equal to dy dt divided by dx dt. you probably don't remember parametric equations like at all from last year because it's literally one section of pre-cal.
Correct.
And it's kind of comical because in AP pre-cal, you're not even supposed to, like, that parametric equations aren't even on the AP exam. So it's kind of comical that they're not on there, and it says, like, only teach it if you have time, and yet it's in calculus, but regardless.
Yeah, I don't remember anything dealing with it.
It's a little different in the context of calculus of what we actually do with it, but anyways. And then the last note thing is the power chain rule. You good back there? Do you need a pencil?
Grab me a pencil.
All right, so the power chain rule says d dx of u to the n, okay, where u is a function with respect to x, okay, is equal to n times u to the n minus 1 times du dx, which is literally just a fancy way to write the chain rule of a power function. Or, yeah,